Welcome back, Zone Squads. Today we're going to talk about right triangle trig. This could be applied in geometry, it could be applied in algebra 2. So let's talk about trig. Trig, what is trig? Trig is the study of triangles. So let's look at a triangle. We're actually going to be focusing on right triangles, so just keep that in mind. This guy here is called theta. It's pretty much a variable, but in Greek terms we just use that as an angle, an unknown angle. We're going to talk about just two places where this theta could be at. It could be here or there. So if I'm standing here, the longest length will always be the hypotenuse, always. So that's always what we remember. So the longest length, the longest side is always your hypotenuse. If I'm standing here, if I'm looking furthest away, this is called your opposite side. And then the side next to you is called adjacent. Adjacent means next to you. So the person sitting next to you is your adjacent. That's adjacent. So this is, if I'm standing here, this is opposite, that's adjacent. However, same triangle, if I'm here now, if I'm standing on this side, this is still your hypotenuse, but now where is your away? The furthest away is your opposite, and then the side next to you is your adjacent. So that's important to know because we're going to have to use opposite adjacent hypotenuse to be able to solve trig functions. Alright, so there are 6 trig functions. There's sine theta, cosine theta, tangent theta, and then there's the reciprocal ones, cosecant theta, secant theta, and cotangent theta. Remember, theta is an angle. Alright, so sine, if you learn back then, we use SOHCAHTOA. So sine, cosine, tangent. So sine, cosine, tangent. The O stands for opposite, the H stands for hypotenuse, the A stands for adjacent. But that's how we're going to do those problems. So sine is so, opposite and hypotenuse, so it's going to be opposite over hypotenuse. Cosine is because, adjacent over hypotenuse. Tangent is TOA, opposite over adjacent. These guys, I wrote next to these guys because these are actually the reciprocal of them. So cosecant is going to be 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. But because they're reciprocated, we can reciprocate these guys. So instead of opposite over hypotenuse, we're going to say it's hypotenuse over opposite. Instead of adjacent over hypotenuse, we're going to say hypotenuse over adjacent. Instead of opposite over adjacent, we're going to use adjacent over hypotenuse. Alright, so we're going to use sine, cosine, tangent in order to find other sides and other angles of a triangle. Usually when we have 2 out of the 3 sides, if it's a 3 here and a 4 there, and it's a right triangle, how can we find this guy? What theorem did we use? Started with the P, Pythagorean Theorem. We can say it's a squared plus b squared equals c squared. However, if 2 sides aren't given, but one side's given and an angle's given, we can still find other sides of the triangle given by using sine, cosine, tangent. So we'll look at a couple examples, and then we'll do 3 practice problems I want you guys to try. Alright, first example, let's try this. I give you 2 sides. I want you to write the 6 trig functions. Well, we need this third side, but because 2 of them are given, we can just go straight and use Pythagorean Theorem. So leg squared plus leg squared equals hypotenuse squared. So we square that guy, we get that, we get 61 equals that, and we square root it. I'm using my calculator for this, but you square root of 61, you get roughly 7.81. So this is roughly 7.81. Make sure the hypotenuse is always the longest length out of all these sides. And then how do you do the rest? Well, sine, cosine, tangent. Sine is what? So opposite of hypotenuse. So if I'm standing, let's say I'm standing here, then opposite is my furthest away, so it's my 5. Hypotenuse is the longest length, we get that. Cosine is adjacent, which is a 6, the person next to you, over hypotenuse. And a tangent is opposite over adjacent, so it's 5 over 6. So how do you find Reciprocal ones, cosecant, secant, cotangent. Well, you just flip these guys. This is 7.81 over 5, 7.81 over 6, and then 6 over 5. So these guys are pretty easy once you have those guys. Alright, so once again, if I have two sides, we find the third side. From there, we can use subtotal because we need opposite, we need adjacent, we need hypotenuse. Alright, let's try one more problem. Alright, let's find other parts of the side. So last example together, if I gave you this triangle, and it's a 30 here, 10 there, x there, and y there, I want you to find x and y and maybe this angle here. Alright, so we know this angle is a 30, 60, 90, it's a special right triangle. We're going to talk about that when we talk about trig. Well, if I want to find x, that's adjacent and I have hypotenuse. So what's adjacent and hypotenuse? That's cosine. So cosine of 30 equals adjacent over hypotenuse. We set up an equation, now we solve for x, so you just have to multiply by 10. So x is going to be, let's try that, 10 cosine of 30, which is going to be 8.66 roughly. So this guy is 8.66. And from here, we can use Pythagorean Theorem to find this guy, or we can use trig again. Let's use trig again. So opposite over hypotenuse, you can say sine of 30 equals opposite over hypotenuse, same thing, multiply by 10. So it's 10 sine of 30 now, and we get 5. So this guy is 5. Okay, so all trigs, we're using trig, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, good job. So this concludes our lesson. We're going to do 3 practice problems, basic, intermediate, and advanced. All right, your basic problem. If I give you a triangle, and then let's say theta's up here now, you have 12 here, 9 there, and then C here. I want you to find C. So how do you find C? I'm going to give you about 30 seconds to a minute. Try some theorem. That's your hint. Go. Alright, welcome back. Let's try this. So it's 12 squared plus 9 squared equals C squared. So 144 plus 81 equals C squared. And let's do that. So you have 225 equals C squared, and then square root the answer. We get C equals 15. So this is 15. Once again, it's the longest length compared to 12 and 9. All right, check your answers, make sure you got it right. That's your first basic problem. Let's move on to intermediate. Intermediate, given sine theta is 7 over 10, find cosine of theta. Tough problem. Draw out a triangle, find the hypotenuse, or find adjacent since the hypotenuse is given. Find adjacent, and then find the rest. Okay? I'm gonna give about 30 seconds to a minute. Go. Alright, welcome back. Let's draw that triangle. Let's say I'm standing there. Sine is opposite over hypotenuse, so opposite over hypotenuse. Find that guy. Your goal is to find that guy. Well, we can use Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. So you have 49 plus x squared equals 100. Subtract 49. So if we subtract 49, we get 51. Square root that. So x is going to be square root the answer. You get roughly 7.14. So this guy is roughly 7.14. So to find cosine, what is cosine of theta? It's adjacent over hypotenuse. So adjacent is 7.14, hypotenuse is 10, so that's my answer. All right, check your answers, make sure you got it right. We're almost there. Let's get to our advanced level. All right, we made our last problem, advanced. If I give you a triangle, I'm going to switch the triangle up. And then here's that. I give you 60 degrees here. I give you x here, 5 there, z there. I want you to find x and z. All right, try to figure out where you're standing. We have to use this guy. This is your adjacent side. So what can we use? What cosine, sine, or tangent can we use to find using adjacent? So I'm going to give you about a couple minutes. Try it. Go. All right, welcome back. So let's find x first. So it's opposite adjacent is tangent. So if you use tangent of 60 equals opposite over adjacent, so multiply by 5, you set up an equation. So what is that? It gives us roughly, plug it in, 8.66. So this is roughly 8.66. We can use Pythagorean Theorem to find this guy, but let's use trig again. Let's do adjacent over hypotenuse. What's adjacent over hypotenuse? Get the practice as cosine of 60 equals adjacent over hypotenuse. This is where it gets a little tricky. Kids get a little confused here because the variable is the denominator. How do you get rid of it? Just multiply by z on both sides. You have z cosine 60 equals 5. Cosine 60 is a number. It's not a variable, so you could divide by that. That cancels. So if you do 5 divided by cosine of 60, we get 10. So then z is 10. And then this guy here, what is this angle here? It's going to be 30, 60, 90, so it's 30. So check your answers, make sure you got everything correct. That concludes our lesson for right triangle trig. Hopefully this lesson helped you. We're going to do a lot of other trig properties and rules and graphing them and unit circles, so there's lots to come. Please subscribe to my channel. Please turn on your notification. Let's get ready for some math videos.